Okay, don't miss a moment. Follow Data Science Conference's social media for the latest updates and stories. And it's time for our next talk for today. It is reserved for the bronze partners of this year's conference, Xintio, who have significantly contributed to achieving everything we envisioned. This is another milestone in our long-standing collaboration, and we hope there will be many more. Next, we have Darija Strmecki Lamia Cero, Senior Data Engineer and Data Engineer at Xintio, respectively. They will be presenting the waiting game, how CI, CD disasters and endless PR delays are costing you time, money, and sanity. In this session, Darija and Lamia will discuss the hidden costs of inefficient CI/CD pipelines, from lost productivity to increased operational expenses. Drawing on real-world experiences with AWS PR validation processes, they will share actionable strategies to optimize pipelines, save time, and reduce team frustration. Please welcome Darija Strmecki and Lamia Cero to the stage. Welcome, ladies.
Thank you. Okay. Ooh. I don't know, we should wait for the people to leave, or we can start. Okay.
Thank you.
Cool. I'm just going to start probably yell until the people leave. Good presentation. It was the bar is pretty high. Okay, so today my colleague Darija and mentor and myself are going to talk about something that I think a lot of people experience who are in the tech world. This is kind of out of our personal frustration, this presentation, and yeah, okay, so I can assume that some of you sitting here have faced the long and wasted hours on waiting for your pull request to be approved, only to be told that you need to fix something, or when the CI/CD pipeline is broken, you're unable to do your jobs, to finish your task, and it's just an endless cycle of delaying your project. Okay, if you've been there, you might find some value. We hope that you will find some value and some solutions on how to tackle these problems. Okay, when we talk about CI/CD, we're often told that it is something that should speed things up, but what happens when faster turns everything, when faster slows everything down? Your project gets delayed, many hours of your developers get wasted. Effectively, you're losing a lot of money, and of course, your efficiency is stuck in a vicious cycle of frustration and delays and so on. These delays don't just impact the whole development, but they impact the workflow in general, so from deliveries and of course to team morale, which is something that we often ignore. But yeah, our goal here today is to talk about these hidden costs and also see how we can take action. But before we do that, we want to cover some real-life stories. The first one is actually, this is something that happened to our own colleagues. They did not make the mistake, but they were working with a developer, and let's call her Sarah. And Sarah was doing some changes on her feature branch, and what she didn't do, she didn't pull the changes from the main branch for, I think it was over 2 months. She didn't care what other people were doing, and once she was done with her task, somehow, nobody knows how, she managed to merge the code, deleting and overwriting everything that was there. So she didn't keep anything up to date. PR processes were in place, but it looked like this. I make the PR and I approve it. So nobody could actually say, hey, you're going to have a conflict here. The second story happened in a very famous auto industry, and this story even made headlines. So this developer, let's call him Philip. Philip was also doing some testing, and what he did, he published his code to a public Git repo. That code contained the things that he was testing, so private API keys, passwords, access credentials, and a lot of sensitive information. Of course, Philip didn't see that in the beginning, and it took him, I think, several days to figure out what was happening, and that gave time the hackers to use that information and, of course, steal sensitive data and probably earn a lot of money. So the reason why we're telling you these stories is because these are mistakes that can happen to any one of us. Sorry. Honestly, lack of concentration it can happen. But we want to talk about how to prevent these disasters from happening and, of course, probably keeping your job. But now my colleague will take the stage to talk more about CI/CD.
So what actually makes the perfect CI/CD? It is way more than just about automation. It is about seamless integration, about swift deployments, but what is the most important, it is about the trust in the process itself. But let's take a step back and first introduce the CI/CD itself. So CI/CD stands for continuous integration and continuous delivery or deployment, and it can be divided to 4 stages: source, build, test, and deploy. In the source stage, it is important to set up the version control to make sure that all the developers can collaborate with each other in an efficient way and not breaking each other's code. Here you also need to take care about the branching strategy and the PRs. By branching strategy means that you will separate your repository to the feature branches and main branches. The best practice is to have main branches with limited access, so the only way to merge the code is through the pull requests with approvals. Feature branches are the place where developers are actually writing the code, getting fixes, updates, etc. By the pull request, when you do the pull request, it will immediately show you all the changes you made, all the changes that will be merged to the main branch, and also it will immediately show you conflicts, so it is a good thing to have, I would say even important and necessary. If you remember Sarah from the disaster number 1 my colleague talked about, her disaster could be easily avoided just by implementing the proper PR strategy and limiting the access for the developers to the main branches. Other thing you can do in the source stage, there are some initial checks such as linting and syntax checks. The build stage is where your code gets transformed into the tangible project. For example, you build a Docker image out of the Docker file. You can also include some preliminary tests here with the focus in the individual component, such as unit tests or static code analysis. The next stage, as its name says, it is a place where you need to do the automated comprehensive testing for your code. Some of the tests you need to do are functional and performance tests, integration tests, security tests, basically all the tests you can come up with to make sure that each part and all the parts together as a whole are working as expected. And finally, the deploy stage. It is where your product is ready to be pushed and merged into one of the main environments. But it is not a perfect world. And in the most cases, CI/CD won't be as perfect as well. We will talk about CI/CD delays and PR delays and issues, and we will go through the 3 important cost types caused by bad CI/CD practices. So the first one is time. Every hour your team spends waiting, it slows down the deployment, and it can cause bottlenecks. It is hard to meet the deadlines when you have bottlenecks and constant waiting. By some researchers, in average, the developer spends 3 to 5 hours per week waiting for approval. That is a serious waste of time. Another aspect here is innovation slowdown. By waiting, your teams lose their time, and instead of focusing on new features, new improvements they could sell to your customer to improve your product, they have to wait because of some stuff that could be avoided. To give you another one example from our own experience, we had a client which company didn't want to invest into the proper CI/CD. And what happened? They ended with the manual approvals which were performed by their manager itself. So imagine all the issues that happened here. First, that is not a priority to the manager. He has his primary tasks. And due to that, the other tasks are either waiting, or you are waiting even more for the PR to be delayed, to be approved because of his other priorities. The other cost type is money. With the extended timelines and missed deadlines, your developer is spending more time on development, and that leads to higher development costs. Every delay in the release pipeline increases the operational expense. For example, even if they are idle, cloud infrastructure resources can still incur some serious charges. And the third, every delay in the releases creates a risk of missing the market opportunities, losing competitive advantages, and by all of that, losing some important revenue streams you could have. Here you can see some statistics where the real businesses talked about issues and actual cost that they noticed by implementing bad CI/CD practice. And last but not the least, the sanity. With constant delays and lack of collaboration, it leads to the decreased morale, and it could cause frustration and the burnout for your developers. The constant waiting game can create a toxic environment where the progress can feel stunted. And finally, the lack of momentum can raise the demotivation, and with that, especially for the high performance, and it can cause the long-term disengagement. You can also see here that for up to 70% of the developers, they noticed the increased stress level due to the bad CI/CD. But okay, we talked enough about the issues. Let's start with the solutions now.
Okay. So taking back control, honestly, we have experienced everything that Darija has mentioned, and we were like, it's enough. We need to change something. So the list that you see here is, so these are the problems that we were facing and the solutions that we applied. This is not written in stone. Anybody, honestly, you can run free with your imagination when it comes with this. So any problem that you're facing, we believe that you can try and implement it and find a solution to the issues that are causing your pipelines to break and any delays in the pull request. So remember Philip from the first story, and with the passwords and credentials being publicly available. So the first step, mandatory attribute checks for resources can be added. You can always add a check to see if something is parameterized or hard-coded, and if it's not, the process will stop and the code will not end up in the main branch in his case. So we're going to go over a high-level architecture of our solution. We provided the first and the main problems that we had. So this is where we started and what we developed. Some of you who are working in AWS might recognize these icons. Once again, nothing is written in stone. It can be applied anywhere. This was our use case. We were working for a client on AWS for a couple of years, and as said, this is why we developed it there. So these two examples are so the first one is state machines. State machines are actually just orchestrations. So here, of course, we always, those of you who are, creating some, state machines and adding some steps to your orchestration might crash the pipeline. So this was happening to me. I was doing a lot of mistakes there, and I don't know, missing a semicolon or indentation error, and of course eventually it crashed the pipeline because my resource couldn't be created because of this. So how this functions? So you create a pull request, and then a script is triggered, which does the whole validation. So in this scenario of the state machine, there is a resource, so there's something called change sets in AWS. So what happens here, let's imagine that the change set takes the changes out of your pull requests, and it creates a copy of the existing resource that is working and on the test environment. What it does, it applies the changes that you created and tries to execute the creation of the resource. So if it fails, a rollback is of course created, and nothing, so the resource that is working it stays intact, so nothing changes there. And a very important step here that we were losing a lot of time is to add an automatic email to notify the developer that his changes will probably crash the pipeline. This is important because from our own experience, how our day-to-day would look like. We would create a PR, the pipeline crashes, nobody notifies us. We have other tasks. It's not our job sometimes, or we don't have time to check if our code crashed the pipeline. The support guys, in our case, we call them the support guys, so those who are actually doing who are approving the PRs, they would be like, oh, sorry, I was on lunch, I forgot. Even sometimes they'll be like, I don't know what to do, how to revert the changes. So you do a lot of unnecessary work rather than focusing on your tasks. And honestly, it was, it was very frustrating because of the communication. And as said, it was an overall big delay. And yeah, in another use case, so the template change is just where you create your resources. I think it's pretty much it's similar as Terraform. Once again, stupid mistakes can happen, human errors, and the resource might not be created. You're missing some attributes or misspelled something. And this is the first step where we started, because when you do a validation of a template, you have a simple command, literally says, validate template, and that's it. If it fails, once again, we go back to the same process. If it passes, the developer is once again notified that his PR has been merged, and automatic merge pull request is triggered. It also checks if you're going to have any conflicts with the main branch, if you by accident change something. So yeah, it also prevents code that will conflict with the main branch to go to the main repo. Okay, so here, honestly, as said, our goal here is to see if somebody faced the same issues that we have, and we kind of wanted to give you a step-by-step tutorial how to start. Where we started, we sat down and we tried to figure, okay, where are we and our developers, we're not blaming anyone, we're starting from ourselves, where are we making the biggest mistakes? And in our case was the templates and the state machines. So we were like, okay, we have to fix this. Then we are introducing a PR validation. So just set up a validation system that is gonna prevent all of the simple errors. So as said, I'm starting very simple, so follow the KISS principle, keep it simple, and then just build on top of it. So start step by step. This will allow you to have automated reviews, and as I said, you don't have to lose a lot of time here, because we were also a part of the, let's say, team who was approving the codes and changes, and as I said, it takes a lot of time. This allows you to detect any bad code at a very early stage, so it will not crash and go to the main branch. Nothing will cause any disruption in the whole development process. And then you have a seamless integration, as it says here. It integrates easily without disrupting the workflow, so this is what we are all kind of wanting. And we can focus our shifts from manual reviews to faster, high-quality code delivery. So as said, this is really something at the end of the day that we want to deliver something fast, especially if CI/CD is here to make our lives easier, not to make it worse. So yeah, if you want to take a picture of this, feel free, or it would be, if somebody finds some value, it would be cool, yeah, that you applied it. And okay, some business talk now.
Yeah, so you heard a lot of things today about improving your CI/CD, but why should you care? Why is this important for your business? Well, first, faster time to market. The less time your team spends on waiting and manual code checks, they will have a lot more time to focus on the features and updates and to deliver them to your customer. The second are the cost savings. By implementing the proper CI/CD, you are reducing delays, and by that you are reducing the operational cost and overhead, and freeing up the resources to make the more impactful work. And third, happier teams. By removing bottlenecks, you are boosting the morale, and you are getting the overall boost in productivity. Believe me, your teams will be very thankful for it. And to conclude, don't save budget on your CI/CD. CI/CD can be a very powerful tool if implemented correctly, and your business will highly benefit from it. By implementing simple but very effective solutions. You can save a lot of time, money, and sanity for you, your team, and your company as well. So take the action now. Improve your CI/CD pipeline and avoid your next disaster. Thank you.
Okay, ladies, if that's all, we have time for questions.
Are there any? Okay, good.
Any questions, please? Yes? Just a second. A little bit of patience.
Thank you for the talk. I'm personally not someone who does CI/CD, but I'm moving into this space, and I wonder if you have some thoughts on trying to atomize the process a bit, because I work with clients who have huge CI/CD pipelines, and I wonder if there would be ways to test parts of the system and not run the whole thing.
I mean, parts of the CI/CD.
Yes.
So if you want to see.
If you have seen this use case.
I mean, in our use case, it's a whole process. I think you could make some tests, but once again, you will use, like, you can test parts of CI/CD. I believe that you will have to create additional resources. And this is not very time consuming, honestly. Like, the overall process takes around, I would say, it depends really on how big the CI/CD is. We did not think about, honestly, that's actually something good to think about.
I'm talking about a pipeline that takes like an hour to build.
Yeah, I get it. Yeah, and you have to wait for.
But I'm touching a small part of the system, and I wonder why is there not a better way to test a small part?
You can take just part of it, but it is maybe the best practice to test everything you can to avoid any other issues that could happen. Of course, there will always be some manual checks due to the logic, and etc. We are not talking about some quality checks, logic checks, and etc. We are talking about parameterization and stuff that can be tested, and it is not something that it must be manual. But yeah, you can test only the part of that, but we recommend to test as much as possible without manual intervention. Yeah.
Do we have another? Yes, please.
Okay.
We have another question.
Thank you for the presentation. You mentioned that the total uplift in the moral and the productivity was about 20%, and I'm interested in how to measure it.
Can you repeat, please, the
Please,
question? We didn't.
Yeah, you mentioned that total uplift in the productivity was about 20%, right? How to measure?
Okay, that are some statistics taken from the online researches and some surveys, for example, GitHub surveys and DevOps pages. We can show you the sources if you want later. You can catch us. We will be here for 3 more days. But yeah, that is not measured by us. That are general statistics.
So it's some kind of NPS score, right?
Yeah.
Yeah. I think that's it.
Is that all? Do we have another question, maybe? Yes, please. Here, in the 4th line.
Thank you for the presentation. Sometimes I think it's difficult to implement some jobs in pipelines, but do you think if you have a long-term project to rely on some proprietary libraries or tools, or should we invest some time to investigate some open source or free tools to have these jobs customized by our own? What do you think about this?
It is always good if you have some long-term project and you need to calculate it for yourself. For example, if you are losing a lot of time instead of developing to do checks, you need to see how much time will it get to you to do the custom testing, and if it is if you can do it fast, it will save you a lot of time during the other part of the project because you won't do that manually anymore.
Okay, thank you.
But it depends.
We have time, so there's a time for another question.
I think it's...
Okay, thank you very much. Dear ladies, thank you on
Thank
behalf
you.
of the organizing team. This is for you, for being a part of
Thank
Data
you so
Science
much. Thank you.
Conference.
Thank you.